guys, this is problem 73 of Neetcode 150 word search. Alright, so we're going to be given a 2D grid of characters board, and we're going to be given a string word, and we're going to have to return true if somehow the word is found here. Okay, so for example, we have this grid, and the word that we're looking for is cat in this example, and they're showing us with the yellow squares that we can have cat. And good thing for us, actually, we don't have to use the diagonal, so it's only going to be right, left, up, down. Okay, so if they ask for, let's say, tack, well, that will have been right. If they ask for bat, right, it will not have been correct because you can't find a bat, B-A-T, in this example. Okay, so I think I will actually go through the code itself because there are not too many ways to explain this on a whiteboard. Basically, what we're going to do is that we are going to use a depth first search for every single value, right? So we're going to say that for each row and for each columns, right? So we're going to go for every single numbers, and we're going to send a recursive call, and our logic is going to be that if basically we arrive out of bounds, we return false if the number that we are at is not a number in the word, right? For example, if we have B, if we want to find cat, and now we have C A, but then we have C A A, so if that A is not T, right, we want to return false, okay? And if we ever arrive to, let's say we want to find cat, right? If we add one letter, 2 letter, 3 letter, we see that cat has 3 letters. So if we actually have a partial solution with 3 letters, it must mean that we have cat, right? Because otherwise the other possibilities is that we went out of bound, and if we go out of bound, we return false. Or the other possibility is that if that value is not the exact same that we're looking for, we are basically gonna return false as well. So what we are gonna be willing to do also is to make sure that we remember the path that we visited, so we don't go through them again. So let me first create the value rows and the value calls. Okay, and the rows and calls will just be equals to the length. So for example, the rows is just going to be equal to the length of the boards, and the length of the columns is going to be equal to the length at whatever index, because all the rows are basically of the same length. So we're going to say we're going to set these two values, right? And we're also going to set a path that will be equal to a set. Okay. And now we know that eventually we're going to have to define our depth first search function, our recursive function. We don't need to know exactly what we're going to pass to it yet. We just know that after this we're going to go for every single row and every single column. So we're going to go for row in the range of the length of rows. Okay. And for each rows, we're gonna go for every single column. So we're gonna say for C in, can't write tonight. So for C in the range of the I messed up here. So all right. So for all the rows, and also for C in the range of calls, as we define it above, right? We know that we are gonna call our recursive function. So we're gonna say VFS, and we're gonna pass to it what the values we have. So we have the row and we have the columns, and we are also gonna have an index. All right, so let's keep track of the index, which is basically going to be the value that we are at. Okay, and what we want to do with this is that we want to make sure that the depth first search function returns either true or false. So we know that if we say if and we call this function, we are going to retrieve either true or false. So if this is true, this statement we want to return is true. All right, so after this we can return false if we never return true. All right, and now we can actually define our depth first search function. So the first thing we want to pass in is the row, the columns, and also the index. So it's going to be I. All right, and now basically, if you remember the logic, we know that if we arrive at an index that is out of bound, or if we arrive to a value or a letter that is not the letter that we expected, we are going to return false, okay? But if we never return false and our numbers appears to be the length of the word, right? It means that we added the exact value that we are looking for. So we are going to say if I is the length of the word. So this is the only case where we want to return true. All right. The other cases that I can think of, it's basically all the out of bounds errors. So we're going to say, so we're going to say basically, if the row is negative value or if it is lower than 0. So what I can think of is if the row is smaller than 0, or the column is smaller than 0, right? And now we can keep going like this and think of all the possible values. What if the index of the row is actually greater or equal to the rows, or same thing with the columns, right? Okay, so this is good. What else can we think of? So we can add another statement. What if the word at the index I? So word at the index I. So what if this is not equal to the word that we expected? So we can do so by saying word at the index of that row and at the index of that column. So let me just break that into a couple statements here so it feels a bit clearer. All right. Okay, so now we check if we are out of bounds, or if the value that we are looking for is not the one that we have. We also want to make sure that the value or the row and the columns that we are at is not something that is already in the path. So if we have a value that is already in the path, which is going to look like a tuple with R and C, we're just going to return false. So if any of these statements appears to be true, well, I know that I want to return false right away. Okay, and now this is where we can start our depth first search function. So what we're going to say, we're initially going to add the R and the C in the path. So we know we visited that. So we're going to say path, and we are going to add this basically R and C so that the specific place that we are at. And we are going to call a recursive call this way. So let's just add this value called res for results, and we're going to add all our recursive calls in this. And after this, once we go back of this at each level of this recursive call, we know that we want to make sure that we remove the path that we just did, so we can go see another direction that is crucial. And at the end, we want to return the rest. So it's going to tell us basically if we have the word in it. So it's a lot of code, and there is still more code to write because we actually have to write our depth first search function. So we are basically gonna have to go see the right, see the left, see the up, see down. Okay, so there are 4 depth first search calls we want to do. So first, what if what we want to go see the value to the right? So we're gonna say row plus 1 while keeping the column the same. We always have to increment I by 1. Okay, so if or we're gonna use the or we're gonna use or here because only one of these has to be through in order for us to return true as well. So we're gonna call this again, but now instead of going to the right, we're gonna go to the left. So we're gonna do so by saying r minus 1. And now you might see the importance of these if calls because we are gonna always recurse with one value to the right. So we're gonna go see right, 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 right. Now we're gonna go see left, 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 left. But it is possible that r is eventually negative or is positive, and this is where we want to return false. Okay, that's cool. Now what do we do with the columns? Because now we went up, went down. We didn't went up, we didn't went down, so we have to go up. So we're just gonna add 1 to column. So this is one of the recursive call, and this is also why you want to check here if columns is actually out of bound in positive directions or if it is out of bound in the negative directions. And lastly, our last call is gonna go see the columns minus 1, just like this. All right, so for each row and for each columns in each row, we are going to use this recursive call. And this recursive call, for example, we're going to start at, let's say for r in the range row, so we're going to start with 0. And now for c in the range calls, well, we are going to start with 0, 0. So we're going to go see a, and our a is going to start this depth first search call. All right, but now we can see that right away we hit this first statement that is right here. So the word at the index 0, right? So if our word is cat, the word at the index 0 is going to be C. But we notice that the C is not equal to the word at the index of that row 0 and that column 0, which is A. So we're going to return false right away. So we're going to go see our second letter. So right, we're going to go back to here. We're going to say for C in range calls, and now we have B, and once again we're going to go see that B, so the word at the index I is not going to be B, right? So we are going to return false again. Now we're going to go again in this for loop, and we are going to add C, and now yes, C is actually this value. We are not out of bounds, but the letters I is quite not there yet, so it's not the length of the word, so we are not going to be turned through. So we're going to go here, and we are going to go ahead to the path, basically the row at the index 0, or the first row, and the third column here. So C, right? So first row, third column. So we're going to add this to the path, and now we are going to call or for depth first search function. You can see right away that this depth first search call, which calls column plus 1, is going to go up, but it's going to be out of bound because there's nothing above C, so it's going to return false. Okay, now we have a function or 2 calls where we go to the right or the left are going to reach this this if statement here. So we're going to see that the word at this I is not equal to the second letter. So we see that the second letter is going to be that we're going to be looking for is A. So word at index 1, right? Because in our call we initially increment I by 1, and we're gonna go see that the word at the index 1, which is A, is not going to be equal to that value at the right. So D is not equal to B here. So we're going to return false on both right away. So the only call that will persist through it is going to be the call that goes down by 1. So it's going to be the call that we go see A. And the call that goes see A, once again, is going to have itself 4 recursive calls. You can see that the value to well, we can see that on each recursive call, we are going to increment I by 1, and I was already 1, so now I is going to be 2. And we're going to check if the word at the index 2, so it's going to be T, is that equal to the value to the right? Yes. Is that equal to the value to the left? No, return false. Is that equal to the value to the top? No, return false. Is that equal to the value to the bottom? No, equals false. So we know that we're going to go to the right. Okay, and now we go to the right, we have a T. And for the T, again, we are gonna call our depth first search function, but right away we can see that once we incremented I by 1, we have an I of 3. So we're gonna go see here, and we notice that I is actually equal to the length of the word, which is 3. So we return false. We return through, right? So now we return through, and here in this call depth first search, we see that if true, so yes, return through. Okay, so that's the algorithm. I mean, it is not obvious at first glance, but once you understand it, it makes sense. So we got an error. So boards is not defined. That we mean board. Yes, I think we just So they don't define board with a S. Excuse me. So let's see if that was the only error. And yes, awesome. So I hope you enjoyed this video, and I hope to see you in the next one.